It brings me to the first speaker for Flower Monthly, and that is Mohammed Nazari. You would have seen him in many other Flower Labs events. He is one of our leading experts in various kinds of security and privacy and has how that interacts with Federated. And he's here to talk to us about Flower Intelligence and see, what are the updates in that direction. So I'm going to hand over to Mohammed and see what he has to share with us today.
Great. Hi, everyone. I'm Mohammed. I'm a research scientist at Flower Labs. And today I'm going to talk about Flower Intelligence, one of the recent projects at Flower Labs. All right. I would like to say that the decentralized AI actually leverages a two-phase approach, and it's the training phase and then the inference phase. And I think all the people in this presentation, they're familiar with decentralized and federated learning, where how different entities actually they train a model without sharing data. And essentially, we have different entities with some local data, and then we have a centralized server. The server starts with some random model, communicates that model to those clients. They do the local training, and then they send back the updated models to the server, and the server performs some kind of aggregation and then communicates back the updated model to the entities. And we continue this process until we achieve a converged model. And that is the training and federated learning part. But now, once we have the converged model, actually comes the next challenge. And the challenge is how do we use the model in practice in a safe, efficient, and a scalable way. Because federated learning itself actually resolves some issue and risk for us, where we can avoid any direct access to the local data. And with some privacy enhancing technologies applied, we can make the whole process of federated learning secure and private. And once we have the model, actually, we need to do the inference, but the inference itself comes with some risks. And generally, there are two approaches for performing the inference and deploying a model in a decentralized setting. One is cloud-only inference, and the other is edge-only inference. But the thing is that each of these approaches, they come with some challenges. For example, in cloud inference challenge, we can have the privacy and regulatory constraints because data actually leaves the client or the entity, and that can cause potential violation of different laws like HIPAA, GDPR, and etc. The other issue is that we might have latency and reliability because the cloud inference itself introduces a latency, and also those clients and the entities, they need the connection to internet. The other thing is actually the cost and the scalability. The cloud compute itself it has some costs, and those costs can grow with the usage, and that usage could be the per token, per image, or other metrics pricing. And the last thing is the bandwidth impact, because suppose in a decentralized setting, the clients, they constantly uploading large images for inference or any other type of data to the cloud, and that actually consumes bandwidth and energy. That is about the cloud inference challenges. But on the other side, local only inference also comes with some challenges. For example, the first and the obvious one is the limited compute and memory, because there are some certain like high complexity models that they need like powerful devices, and some devices they don't have that capacity. The other thing is the update and the maintenance, because when we make the AI models live on the devices and the entities, we also need to update them. And if we only do a local inference and actually cut the communication to the devices, updating them is becoming a challenge itself. And the last one is the collaboration and the federated improvement gaps, because those local entities and devices, they also need to provide some performance feedback into a centralized system so we can improve the model and deploy an updated model to those clients. So the thing is that actually neither solution is sufficient on its own. We cannot rely only on cloud inference or only on local inference. And that's actually where we have introduced Flower Intelligence at Flower Labs. It's an open source on-device AI with confidential remote compute. So Flower Intelligence prioritizes on-device inference for speed, privacy, and offline use. But as I mentioned, there are cases that the device is not powerful enough to run the workload. And in those cases where we need the extra power, Flower Confidential Remote Compute actually steps in as a seamless private extension of the device. And Flower Confidential Remote Compute actually doesn't compromise privacy, security, or performance. So with Flower Intelligence, we can have a hybrid approach of local inference and cloud inference. Flower Intelligence has some SDKs, and they're in TypeScript, JavaScript, Kotlin, and Swift. And you can easily actually install one of those SDKs, and you just specify one of the models, which I'll list later in the presentation. And then you just need to pass your prompt. And in this way, actually, this pulls the model on the device and then performs the inference on the device. So this is for performing the local inference in Flower Intelligence. But if extra power is required, then that call would be redirected to the Flower Confidential Remote Compute, or CRC in short. So CRC provides some data protection. It provides data protection at rest, in transit, and in use. So in CRC, actually, no private information is stored. The only information that we save is regarding the usage, and that's for the billing purpose. In transit, actually, all the communications are end-to-end encrypted, where the keys actually are derived from the hardware using T and confidential compute. And also, it provides the data protection in use. And I'll explain how that works. Flower CRC actually utilizes T's and the NVIDIA H100 GPU in confidential computing mode. We actually would put the LLM inside the GPU, and then the execution code resides in the CPU, and the communication between the CPU and GPU is also encrypted. And then the whole workflow is that the user actually gets a key from Flower CRC. It uses the key to encrypt the prompt. It sends the encrypted prompt to Flower CRC, and the prompt only gets decrypted inside the TE using the private key. So even we at the Flower CRC side, we cannot access the raw prompt. And then it communicates the prompt to the GPU for inference, gets the response again, encrypts the response, and then communicates back the response to the user. And it's only the user that can actually decrypt the response. So it provides a TE guarantee that that's the hardware enforced memory isolation, integrity, and confidentiality. And as I mentioned, even against the host level access. And it also provides some attestation functionality for the user. So the clients, they can verify that the inference is running inside the trusted enclave. And they can check this before sending any prompt. And they also get the key through the attestation mechanism. So currently, these are the models that we support in Flower Intelligence. Obviously, those small models like Llama 3.21b that can, I mean, it depends on the device, but you can run that on your laptop probably using one of the SDKs that I mentioned. But for like bigger models like the Qwen 235b, obviously this cannot be loaded on the local device like the laptop. And for that, you need to call the confidential remote compute. But there are also some models in between that, depending on the case, you can either do local inference or use the confidential remote compute. So all the documentation for the Flower Intelligence are available. You can check it out using this link. And if you're interested about confidential remote compute, you can scan this QR code, and then you register your interest, and then Flower Labs will contact you to provide you with the infrastructure for deploying the model that you want and helping you with the project. And that concludes my talk. Are there any questions?
Thank you, Mohammed. That's a great talk. I see there's one question on Slack. The question is, if they are building an app for a laptop, can they use this?
Yes, obviously. Actually, it depends on what language the app is developed in. But as I mentioned, we support different SDKs. So you just need to import that SDK in your project, and then you can do the inference part either locally or remotely using the confidential remote compute.
Right, makes sense. Um, yeah, I don't see anything else. Okay, so great. Thank you, Mohammed. Great talk. It's a good example of how, we have a broader attention um, at Flower to enabling people with open source to build all kinds of privacy or decentralized forms of AI. So this one is an example of a federated inference in some sense. Yeah, so great. Thank you, Mohammed.